Welcome all of you. We are going to start the lesson sound. So let us go and learn some amazing facts about sound. Okay, now actually what is sound, children? Is it matter or energy? It's obviously a type of energy. So work can be done by sound. Let us do some experiments to find what really sound is. Look at the diagram given here. There's a small speaker and it is connected to a dry cell using some wires. When the circuit is properly connected, you will see moving of some polystyrene balls which is kept over there. But it happens only when the speaker produces the sound. When we detach the speaker from the dry cell, we can't see the moving of balls. How does this happen? Actually, when we supply electricity, the speaker cone of the speaker is vibrated. Now, we call it to and fro movement. To and fro movement. So, we can conclude that sound is produced by vibration. The definition of vibration is also given there. Speedy to and fro movement. That is known as vibration. Okay. Now, here are two simple experiments that we can do to identify what vibration is. Now, as given in the first figure, place your fingers on the middle of your throat and then speak slowly and record what your finger feels. Then speak louder and record what you feel to your fingers. First, you will feel a light trembling to your fingers. The trembling will increase when the voice is increased. Now, how does this actually happen? Now, this is a membrane, because of a membrane, vibration of a membrane called vocal cords in your throat. Now, vibration of vocal cords produces the vocal sound. This is how you have got the ability of speaking. Now, look at the next experiment. You will need a laboratory stand, a piece of thread, small polystyrene ball and a tuning fork. These are the requirements. Now, what is actually a tuning fork? It's a two-pronged steel device like this given in the diagram. Now, you can hit it on a rubber pad and vibrate it. It gives a small sound, then it is vibrated. You can find different tuning forks, children, which vibrates with specific frequencies. Now, first you have to hang the small polystyrene ball using a thread as given there. When vibrating the tuning fork, after vibrating it, you have to keep it near the polystyrene ball. Actually, you have to keep it in contact with the polystyrene ball. You will see the polystyrene ball starts to move when it comes into contact with the tuning fork. Now, actually, it is moving only when there are vibrations in the tuning fork. When if we vibrate it and keep it in contact with the polystyrene ball only, we will see the movement of the polystyrene ball. So what can we say with this? We can get the ball moved here. That means the vibration contains some energy. Actually, you have learned about energy conversions in your previous lessons. There you have learned how the energy is transformed into one form to another form. Actually, what is the energy transformation taking place here? Sound energy to kinetic energy. A movement is taking place. Okay. Let us see how this happens really. Look at this. This is how you vibrate it. You can hear a little sound. You can see the movement of the polystyrene ball when kept it in contact with the ball. Okay, now there's another experiment we can do to identify more about vibration. When you vibrate the tuning fork and keep it on the surface of water, you can see The water is sprinkled by gaining the energy from the vibration. Look at it again. Actually, you can see energy transformation there too. Now, I hope you're clear with that. So let's move on to the next part. Now let's see how to categorize musical instruments according to the part of vibration. Mainly we can identify 3 different parts which can be vibrated in musical instruments. First one is strings, then membrane, then the air column. Here we have classified musical instrument under each category. You have seen all these instruments in your school or somewhere. In the first one, you can see under the first category, you can see a guitar, sitar, violin, harp, and many more. And so many more are there. You will see strings in each of those musical instruments. To produce sound, strings are vibrated in that category. Now, in the second category, the instruments produce sound by vibration of membrane. You can see tablas, bongos, and different kinds of drums. Instruments that produce sound by vibration of air column are categorized in the third group. There you can see instruments like trumpets, clarinets, flutes, and many more. So we can conclude that musical instruments can produce sound by vibrating strings, vibrating a membrane, or an air column. Okay, let's move on to the new subtopic, that is propagation of sound, movement of sound from one place to another place. Now we'll see that we all hear different sounds from our ear. So we can say the sense organ used for hearing is ear. But have you ever heard that astronauts can't hear each other? Have you ever heard something like that? Now, do you know the reason for this? We'll do an experiment to find the reason for this. Okay. Now you will need a bell jar, a vacuum pump, electric bell, dry cells connecting wires, and a switch. Those things are not illustrated. Actually, it is connected here. Actually, electricity is supplied to the electric bell. Then, what do you have to do? First, you have to fix the electric bell in the bell, to the bell and supply electricity. Then you have to connect a vacuum pump to the bell jar as illustrated here from down here, right? First switch on the electric bell and record your observations. Then switch on the electric bell again while evacuating the air in the bell jar using the vacuum. What do you mean by evacuating? That means removing air from the bell jar, right? Then record your observations. Finally, switch on the electric bell again when the bell jar is completely evacuated. Now that means air is completely removed from the jar. You will hear the ringing of the bell when the bell jar is filled with air. There's no problem in that. You will hear the ringing of the bell well, right? Then when it is getting gradually evacuated, when the air is gradually removed out, the ringing of the bell is also gradually fades. Now, when the air in the bell jar is completely evacuated, you will not hear the ringing of the bell. So, what does this mean? Now, what does it clarify? Now, it is clear that ringing of the bell is heard only when there is air in the bell jar. That means sound is not heard in a vacuum, right? So there's no air in a vacuum. Now this proves that a medium is essential for sound to propagate. Now that's why astronauts can't hear each other, as there's no air in the higher space. I hope you got the answer for that with this simple experiment. Okay. Then we'll see how the sound is propagated in water. Now these are the things you will need, your requirements. 3 plastic funnels you need, then pieces of some rubber tubes, membranes of balloons, and a basin. And you need a white tube two to connect the tubes with each other. First, you have to assemble the equipment as shown in the figure, then hold the funnel A and B onto your ears, A and B. And keep funnel C in the basin of water. Then you have to make a small sound near the funnel in water. So you can just tap the bottom of the basin using a pen, right? Simple sound like that. Then you have to record your observations. What will you hear? You will hear the sound made in water well through the funnels A and B. So that proves, what does that prove, children? It proves the traveling of sound through the liquids. Sound can travel through liquids. Okay. Our next experiment is done to prove that sound is propagated in solids. We have prepared what is shown in the first diagram in your primary grades using yogurt cups and a thread. Tell your friend to go as far as possible, keeping the thread well stretched, and speak into the cup. Keep the other cup to your ear. What will you hear, children? You will hear, but your friend speaks very clearly. That proves sound propagates through the thread. Now you just need, for the next experiment, you just need a clock and a long table. Now you have to keep the clock at one end of the table as shown here, and stand at the other end of the table and test whether you can hear the tick sound of the clock. Now, you will see the tick sound of the clock can be heard through the table more clearly than through the air. So we can say that sound propagates faster through the solid medium than gaseous medium. Okay. Now here are some examples from the practical world. Here in the first diagram, you can see a cannon fire. Now, the sound and the emission of the smoke takes place at the same time. But someone who observes this from a faraway place hears the sound after few seconds of seeing the smoke. This is a proof to say that sound travels with less speed in medium of air. Now, in the next picture, you can see a dolphin. We can hear the sound emitted by dolphins more intensely when we are in the water. Now, divers can experience this well. But when the same sound is emitted above the water, it is heard very lightly. The reason is actually the sound travels faster through water than through air. In the next picture, you can see a train. You can hear the sound of train coming from a faraway place clearly if you keep the ear on the rail line. Now, even if you can't see the train, actually this is very risky, so please don't try it. Actually, the reason for this is that sound travels faster through solids than through air. Right. You got to know some day-to-day instances where we can compare the speed of sound in different media. So here is the actual speed of sound in those media. In air, it's like 330 meters per second. In water, it's like 1500 meters per second. Then in solid media, it's 4500 meters per second. So you can clearly compare these values and see that the highest speed of sound is in the solid media and the least speed is in air. So let us engage in this activity to see whether you have acquired the knowledge well. Look at the first question, children. Fill in the blanks using the words given below. The words given are speed, solid, a medium, vibrations, and air. Okay, let us see the first one. Sound is produced by, what is the answer for the first one? Vibration. The answer should be vibrations. Second one, blank, is necessary for the traveling of sound. What is necessary? Of course, a medium is necessary. Next one, sound travels more faster through blank medium. In which medium? Through solids. Good. Sound is produced in fluid by a vibration of air column, air, right? We'll go to the second part. The musical instrument that produces sound by vibrating strings is, drum and the pair of tabla. Both of them produce sound by vibration of the membrane. Then violin and flute. Uh, Flute produces sound by vibrating an air column. So definitely the answer is violin. We'll go to this next part of the question. Consider the following statements. You have to select the correct statements out of the three given there. First one, sound travels through a vacuum. Now that is not true, right? We got to know from an experiment where we used a bell jar and an electric bell, right? There we identified, we got to know that sound cannot be propagated in a vacuum. A medium is necessary, so that is wrong. The speed of sound in air is higher than the speed of light. That is also not true. Why? Now, nothing can exceed the speed of light. Now, speed of sound is, we can't say speed of sound in air is higher than the speed of light. That is not true. So, we'll go to the next one. A medium is essential for the traveling of sound. Of course, we got to know that from several experiments that a medium is essential for it to propagate. So, the correct answer is C. So, answer is C only. I hope all of you got the correct answer for all these questions. If you got the answer, all of them correctly, then you have listened to me very well. Okay. I hope you all gathered some knowledge from this lesson. We will meet again with another lesson soon. Thank you for joining the class.